Welcome to the AI Research Roundup. I'm Alex. Today we're looking at a paper from the Hugging Face trending list, published on September 29, 2025, about 3 days ago. The big headline is that a compact QWin-38B model, trained with supervised fine-tuning plus reinforcement learning with verifiable rewards, jumps from about 4.4% to about 23.6% on EnvBench-Python and performs on par with QWin-332B and GPT-4o. The paper is titled PI-PER, on-device environment setup via online reinforcement learning. And as we'll see later, the results are really impressive. In short, the authors automate environment setup by generating bash scripts using an LLM-as-a-judge for rewards, and they show strong transfer to Repo2Run with modest gains on Terminal-Bench. Also, the authors shared a GitHub repo. You'll find training and evaluation code under Piper, Hydra configs, UV setup, and ray-based runners to reproduce results. It includes commands to launch experiments, model checkpoints and datasets on Hugging Face, and scripts for EnvBench and Repo2Run evaluations, plus submodules and examples. On Hugging Face, you'll find Piper full 8 billion and RL only 8 billion weights, plus datasets, evaluations, setup instructions, and simple text generation usage examples. Figure 1 shows a two-stage training pipeline that turns a compact model into a stronger environment setup assistant. The top panel illustrates supervised fine-tuning, where the student large language model imitates a teacher's shell script so its output distribution moves closer to the teacher. The lower panel illustrates online reinforcement learning, which scores a generated script using a proxy reward from a judge model and then updates the policy with a reinforce++ step. Well, Figure 2 shows training rewards rising under RLVR, which means reinforcement learning, guided by a judge model that scores scripts. The left panel shows the base model climbing from near zero to a moderate plateau. The right panel shows the SFT model starting high and leveling quickly. Blue tracks training and orange tracks validation, and the small gap suggests little overfitting. Both curves improve over roughly 45 steps. So Table 1 distills how the approach transfers beyond EnvBench. This table compares models on Repo2Run and Terminal-Bench using pass at n, which means a run succeeds if any of n attempts works. On Repo2Run, PI-PER reaches 103 successes. QWin-332B records 71, showing the smaller model leads. On Terminal-Bench, PI-PER totals 4. The RL-only variant reaches 9, and the SFT-only checkpoint drops to 2. So, Table 1 showed transfer, and Figure 3 shows scaling with attempts and the cost efficiency of each model. The left panel shows success rising with more tries, where PI-PER tracks close to GPT-4o and QWin-332B, while far above the base QWin-38B. At 5 attempts, PI-PER reaches about 27 successes. The right panel plots average performance against price, which highlights that PI-PER delivers roughly 19 successes at a much lower token cost than larger systems. This matters because users can attain comparable reliability while spending less, so the smaller model becomes practical for on-device runs. Alright, 2 takeaways stand out. A compact QWin-38B, tuned with supervised fine-tuning plus reinforcement learning with verifiable rewards, delivers near-large model reliability at much lower cost, and the gains transfer across datasets. The bigger implication is practical. On device automation for environment setup, the multi-turn agents remain tricky. That is it for this episode of the AI Research Roundup. I am Alex. Thanks for listening.